Hey guys, this is Miss C here. Today we are going to look at solving quadratics by completing the square. And so I first want to look at number one and then kind of talk through the steps that you're going to take to solve quadratics by this method. So if you look at number one, your first thought might be, oh, I want to try to factor this. And so we are pros at factoring now. And so if we do that, we get our terms of our first term, which is x and x, and then we look at our last term, which is 54, and we go through and we get 1 and 54, 2 and 27, we get 3 and 18, and we could keep going down, guys, but what you're going to end up seeing is that there are no factors that multiply to negative 54 and add up to negative 10. And so work through it and see this for yourself, but we need to see how to solve problems like this when we don't have two factors and we can't solve an equation by factoring. So that's where this new method comes in of completing the square. And so what that means to complete the square is to create a perfect square trinomial. So if you guys remember, if we had x plus 3 squared, this is what that means, because if you think about what a square looks like, the side lengths are the same, right? So we have x plus 3 and then x plus 3 on this side of the square. So that's why it's called completing the square like this. And then when this is multiplied out here, we get x squared plus 6x plus 9. And these are equivalent functions, right? And so that's what we're trying to create here through some algebra in order to solve this quadratic. So let's look at this problem and look at the steps that we have at the top here. And so it says first step is rewrite so all the terms containing x are on one side. So that means we have our x squared and we have our negative 10x. So that means you are moving your constant to the other side of the equation. So we are going to rewrite this as x squared minus 10x, and then we're going to add 54 to both sides and get x squared minus 10x equals 54. All right, so now now number 2 on our steps right here says find the number that completes the square on the left side of the equation. Add that number to both sides. So I wrote this little mnemonic that I use. It's half it, square it, add it. And so that's kind of what I repeat in my head when I am trying to know what number I need to add to both sides of the equation to create this perfect square trinomial, okay? And so the goal of this, guys, is to have the left side of the equation. We need a number right here to make this a perfect square trinomial, okay? And so what we're going to do is we are going to take our b term, so in this problem it's negative 10, and we're going to half it. And so half of negative 10 is negative 5. And then we're going to square it. And so we have negative 5 squared, which is 25. And then we're going to add it to both sides of the equation. Okay? And then now you have created your perfect square trinomial on the left side. So now the left side is going to be rewritten. And we want this to have the form like x plus or minus something and then a constant at the end. Okay, and so the way that we choose our sign that goes in the middle, guys, it's the sign that's attached to b in the middle. And so that means that this is going to be x minus, since we have this minus 10x here. And then the number that we're going to use, well, you have to think, okay, I need x minus something, and x minus, and this number needs to be the same value that is going to give me negative 10 and positive 25, right? So that's where we get 5 and 5 here, okay? And so you can choose how you remember that a 5 goes in this spot. I like to just think it's always going to be half of your b value here is what goes in this binomial that we just created. And the reason that this works, guys, is because if you remember our properties of equality, we added the same value to both sides, so we didn't change the value per se of the equation. We're just manipulating it a little bit so that we can do the work that we want. And so we get x minus 5 squared on one side, and then we get 79 on the right side. And so now, guys, this is why it's so important that you go back if you're still having trouble solving quadratics using the square root method. That's exactly what completing the square sets us up to do, because now we're able to take the square root of both sides and find our value for x, okay? And so once we take the square root of both sides, we're left with x minus 5 equals the positive square root of 79, as well as, let me erase this over here, as well as the negative square root of 79. Remember, when we square root a term, we have to take into consideration both the positive and the negative values that we get there, okay? And so then once we do that, we can add 5 to both sides of the equation in both of the equations that we just found. And we get two values of x equals 5 plus the square root of 79 and x equals 5 minus the square root of 79. So these are our two solutions. And see, you would not have been able to find those by factoring. That's why whenever you get a square root in your answer, this is why this method is so helpful. And so guys, so number 2 is really similar to number 1. And so pause the video and take a minute to solve number 2 on your own to see if you can follow the steps that I took in order to solve number 2. And I am going to just write some very brief steps. I'm not going to write down everything in detail so that you can check your work, as well as I'm going to write the steps that you, or the answers, your solutions for x equals. So pause the video. Okay, and the what you should have gotten for your perfect square trinomial was x minus 9 squared equals 4. And then once you do some work and you take the square root of both sides, you get x equals 11 and x equals 7. Okay? So if you had questions on this, go back and work through it again and look through number 1 and come to class with questions. Okay, and so number 3, same steps that we have at the top here. We first want to make sure that all of our x terms stay on one side and we are moving our constant to the other side. So we're going to add 72 to both sides, okay? And so we have x squared plus 6x equals negative 8 plus 72 is going to be, sorry guys, 64, okay? And so now this is where we need to think about, we're going to take our b value right here, our 6, and we're going to half it and get a value of 3, and then we're going to square it and get 9, and now we're going to add it to both sides of the equation, okay? So now we can rewrite this left side into our perfect square binomial. And so this is rewritten as, remember, you get your sign from the sign attached to b here. And so it's x plus 3 squared equals 73. And now we're just using the square root method to take the square root of both sides, and we get x plus 3 equals the square root of 73, and x plus 3 equals the negative square root of 73. And so then x equals negative 3 plus the square root of 73, and x equals negative 3 minus the square root of 73. So here are your two solutions for this problem, okay? So try number 4 on your own, very similar to what we just did in number 3. And for this one, I am only going to write the solution here. And so pause the video. And the solution to number 4 is x equals negative 10 plus or minus. This is just a shorthand way of writing the two solutions. You have negative 10 plus the 5 square root of 7 or minus the 5 square root of 7. So yes, those are your two solutions there. And so, okay, now we're going to look at number 5. So the important thing here, guys, is you want to complete the square when a is equal to 1. That is the way that completing the square is the easiest and the only way we're really going to practice completing the square in this class. And so whenever you see a not equal to 1, solving by completing the square is not the best method to use. And so if you see that on a worksheet like this, you first want to see, okay, is there a GCF that can be taken out of all of these values? And in this case, there is. And so when that's the case, you can divide everything by the GCF. And so the GCF in this problem is 3. And so when we divide everything in the equation by 3, we're left with x squared plus 2x equals 4. Okay, and so now this looks exactly like one that we want to work with to complete the square. So we are going to take our b value again and then half it. So half of 2 is 1. 1 squared is still 1. So we're going to add 1 to both sides. And so our binomial that we've created is x. Think about the sign you're going to use. And it's going to be x plus 1 squared equals 5. Solve by square root method. I'm going to skip the work here for now, but it is x equals -1 plus or minus the square root of 5. And here is your solutions. These are 2 solutions here for this one. Okay? And so go ahead and try number 6 on your own. And again, it is a similar problem to number 5, where there's a GCF in all the terms, and then solve for x. So now that you have paused the video, number 6, the solutions are x equals -5 plus or minus 3 square roots of 2. So these are 2 solutions. This plus or minus here just is a shorthand way instead of writing both solutions like we did in 1 and 3 here, okay? Okay, so if you are confused, stuck, go ahead and work these problems again on your own. There's also more problems for you to try on your own here. So I want you to try 1 through 4 on your own, and I will write the solutions here for you to check your work and come to class tomorrow or on Monday with questions about these, and I'm going to go ahead and write the answers. So for number 1, we have x equals 3 and x equals -1. For number 2, we have x equals 3 plus or minus the square root of 13. Number 3 is x equals 7 plus or minus 2 square roots of 33. And the last one here is x equals 8 plus or minus 3 square roots of 14. Okay, guys, so hope this practice was helpful for you guys of how to complete the square. I want to look at these 2 problems, these word problems that really completing the square is a great way to go about them. So let's see, the length of a rectangle is 4 centimeters greater than its width. If the area of the rectangle is 108 centimeters squared, what are the appropriate dimensions of the rectangle? Okay, guys, so I am going to go through and see the things that I see are important. So I see the length of the rectangle is 4 centimeters greater than its width. And then the area of the rectangle is 108 centimeters squared. What are the dimensions of the rectangle? Okay, so some things that I think of, and first thing I think of is to draw a picture. And so I'm going to draw my rectangle, and it says the length is 4 centimeters greater than the width. So greater than, I think of plus 4. And you can use whatever variables you want. I'm going to use W for width, but if you want to use X or C or B or A, anything you want, just stay consistent with your variables. And then it tells me that the area of the rectangle is 108 centimeters squared. Now I also know that how to find area is multiplying the length times the width, right? And we are given those 2 dimensions in variable form here. And so I can use these 2 equations to find out what my dimensions are. And so if area is length times width, then the area is W, which is our width, times W plus 4, right? Because W plus 4 is our length. And this is equal to 108 centimeters squared. And so now I want to try to find what W is. And so I'm going to distribute my W to everything inside the parentheses and get W squared plus 4W equals 108. Okay, and so now this looks exactly like a problem we were just working on with completing the square. And so you want to take the same steps that you would, where you already have your constant on the right side of the equation, and so you want to take your b term here. And so we have 4, and so we're going to half it and get 2, and then we're going to square it and get 4, and then add it to both sides. And so we have plus 4 plus 4, okay? I'm going to move my work up here. And so my binomial now becomes w plus 2. And remember, guys, how I find the number that goes in this binomial is just what number multiplies together to give me my c term and adds together to get my b term, okay? W plus 2 squared equals 112, and now it's just the square root method, okay? And so my value for x here, or sorry, not x, we have w here, is going to be, we have -2 once you work it all out and simplify your radical and everything. And guys, please use your calculator. Use your technology and your resources there. So I get -2 plus or minus 4 square roots of 7, okay? And so the important thing, though, with word problems, though, guys, is what makes sense. It doesn't make sense to have a negative value for the width. And so our width is really only this positive value of -2 plus 4 square roots of 7. And it asks us for the approximate dimensions. And so you can go ahead and plug this into your calculator and find that the width is going to be 8.58 centimeters. Remember, units is important. And your length, which is w plus 4, is going to be this value and plus 4 more. So that is going to be 12.58 centimeters. Okay, guys? And so a great way to check yourself with this one would be to multiply them together and see if you get 108, or as close to 108 as possible. And so try that, and you will see that you get 107.97 something, which is pretty darn close, if you ask me. So I want you guys to try number 6 on your own. This is a volume problem. So the volume is 96 centimeters cubed. Find the dimensions of the box. So you need to find this. Once you find x, you have to find the width and the length of the box. And I'm going to tell you guys the volume. I hope you guys know how to find the volume of a rectangular prism, but it is length times width times height. And so use that information to try this one on your own. And you guys can try that and then come to class with any questions on it, okay? And so the last thing I want to leave you guys with before we end out this video is just some things I want you to go back through this notes page and see what you notice. I want you to see what is similar in all of these problems that you just did. What do you notice about the B term in every problem that we worked on? Okay, I'm not going to answer that. I want you to reflect and think on that for yourself. And then something else I want you to think about, I kind of explained it at the beginning of the video, but what would it look like visually to complete the square? I want you to think about the area model that we use when we multiply binomials and what is special about the sides of a square, okay? So come back with your thoughts on these two questions. This is going to kind of kick off our class on Monday together. So I hope this was helpful, guys. Have a great weekend.